Good morning everyone. I am Mr. Shankar Kulkarni, Master Graduate in Physics, and also I have completed my Bachelor of Education. And since from the last 13 years I am working as a science teacher for secondary and higher secondary levels. So from now onwards I am going to show you some videos through this YouTube related to some science and maths topics of secondary and higher secondary level. You can use these in this COVID-19 situation for your reference. And also I request you that if you comment on any particular topics of secondary and higher secondary levels in both science and maths subjects, I will make the videos on those topics. I hope you all will enjoy and use these videos for your study purpose. Thank you. Yes, dear students, today now we will start the chemical properties of metals and non-metals. Already what we have studied up to now, the physical properties of metals and non-metals. Physical properties are the hardness. Metals are very hard, whereas non-metals are brisk in nature. Metals are lustrous in nature, that means they are shiny in nature, whereas non-metals are not shiny in nature. And what about malleability? Malleability means it is the nature of the metals of making of thin sheets. Only metals can be made of thin sheets. If you take a cold piece, you can't make of it. That means malleability is present in case of metals, not in case of non-metals. Whereas ductility means making the metals into thin wires. Yes or no? This is ductility. Next property is sonorous. That means all metals can produce the bell-like ringing sound. Okay, that is called sonorous. And if we come for the conductivity, metals are the good conductors of heat and electricity. So up to now we have studied about the physical properties of metals and non-metals. So now we will study the chemical properties of metals and non-metals. Okay, so chemical properties means what? What it is? Let us understand. First thing is, chemical properties means how the metals and non-metals react with oxygen, how they react with water, and how they react with acids, and how they react with bases. These all properties are called as chemical properties. Okay, so let us study chemical properties. Chemical properties. So, under this section, first what we will study, how and when metals react with oxygen, what do they produce? Okay, see, when metals react with oxygen, they produce metal oxides. Yes, and at the same time, when non-metals react with oxygen, they produce non-metal oxides. This is same. For example, when iron, which is called ferrous, when ferrous reacts with oxygen, it is called ferric oxide or ferrous oxide. That is iron oxide or metal oxide. And if we take example of sulfur here, sulfur reacts with oxygen to form sulfur dioxide. That is a non-metal oxide. Okay. And next, when the same metal oxides and non-metal oxides are treated with water, what happens? See here. Now I am taking metal oxide metal oxide to react with water, what do they form? Okay, and when non-metal oxides react with water, what is the product? These two things we will find out now, okay, with the help of a small experiment. So let us study the experiment. So first I will go for the metals. Okay, so my choice of metal today is iron. So what I have done here, this is a watch glass, and in this watch glass you can see the rust of iron. So I have collected here the rust of iron. Are you observing here? Here powder of iron is here. So I have taken an iron rod which is already rusted. I rubbed the surface of the iron rod. So I got this rust of iron. See, rust of iron means what? Already one step is completed. Metals already reacted with oxygen. See, ferrous is a very slow reactive element, iron. Hence, for making the rust, it takes a long time. So already rust is there. So I have taken the powder of that rust. That means this is not pure iron. This is the oxide of iron. Is that clear to you? So here one step is over. Metals plus oxygen is metal oxide. So this is iron oxide or rust. Now what I will do? What is the next step? When we have metal oxide, what we should make? We should make the metal oxides to react with water. Yes. So what I will do now? I will take this test tube. Okay. And now I will collect all this rust. See, I am collecting here all the rust. What I am doing? And see, this is all rust, and I will take the rust in a test tube. Are you observing here? This is what I have taken the rust of iron in a test tube. So this rust of iron in a test tube I have taken. Now next step is I should make it to mix with water. So I will add little amount of water to it. Yes, all of you are observing me here. See here, I have added a little amount of water and I am making it to mix. Proper mixture is happening there. Okay. Yes. So you are observing here that iron rust is mixing with water. This is a metal hydroxide. Okay. Now I wanted to know whether this is an acid or a base. This is my main thing to identify. Now again I will take the watch glass. This is the watch glass. Now the mixture of this I will take in the watch glass. You are observing, I think. Yes. Please come front. This is the watch glass, and in the watch glass, as you are observing, I will take one red litmus paper, because all of you know that the bases convert red litmus paper into blue color. Okay, so this is red litmus paper, and in the watch glass, as you know, this is the mixture of iron rust and water. So I will put the red litmus paper in this. So when I mix this iron rust, red litmus paper, now we are observing that little bit, you can observe here, little amount of red litmus paper is converted into little blue color. Okay, so red is converted into blue color here. Observe. This means that the product of iron metal or metal oxide and water is going to produce a base. How can we say that this is a base? Because always bases have the property to convert the red litmus paper into blue. So that means this is clear that when metals react with oxygen, they produce metal oxides, and when metal oxides are mixed with water, they are going to produce the bases, which we can confirm by converting the red litmus paper into blue. Then what is the next step? Let us verify how non-metals react with oxygen as well as water. So one best example for non-metal is the sulfur. This is the sulfur box, and I will take only small amount of sulfur powder. Okay, and you should be very careful while doing such experiments. See, from this spatula or small spoon, I will take a very small amount of sulfur. This is sulfur powder, yellow in color. And is it a metal or non-metal? Non-metal. Yes, it is a non-metal. Now I want to know how this non-metal reacts with oxygen as well as water. So what I will do, reacting with oxygen means what? We have to burn it. You know the process of burning. Burning takes place when oxygen, heat and burning material are present. Okay, so now I will light a candle. So first I will light the candle. So as you know, now I am going to burn the sulfur. Burn the sulfur means I am going to mix the sulfur with oxygen to produce sulfur dioxide. Okay, so you will observe one gas will come out of this one, and the resulting gas is nothing but sulfur dioxide. Okay, so it is, see, sulfur has catched the fire. A smell is coming, particular smell is coming. The smell is of sulfur dioxide. Okay, a gas is coming, and I will collect this gas in a gas jar. I will close the gas jar with the lid. You are observing one gas is collecting in the gas jar. Yes, all of you are observing this.
Yes, sir.
Gas is collected in the gas jar. So much of gas is collected here. This is nothing but sulfur dioxide. Okay. I will stop burning of sulfur because this much gas is sufficient for our experiment. So I will stop burning of this one. So here I have collected the sulfur dioxide. So you must be very careful while doing such experiments. So now what is our next step? I have mixed a non-metal with oxygen to produce non-metal oxide, that is sulfur dioxide. Now I need to do the mixture of non-metal oxide with the water. Yes, so I will add little amount of water to this gas. Yes, you are observing. Now sulfur dioxide is mixed with water. That means non-metal oxide is mixed with water. Okay. Yes, this much is sufficient. Proper mixture of sulfur dioxide or non-metal oxide and water is done. So now I need to verify whether this is an acid or a base. Whether non-metal produces an acid or a base. How to verify that? With the help of litmus paper. As we know, bases convert red litmus paper into blue. Acids convert blue litmus paper into red. So I will collect this in a watch glass. I will take another watch glass and I will collect a very small amount of this product in a watch glass. You can see a very small amount of this I have taken. I am going to keep this on here. Now I will take one piece of blue litmus paper. Okay. Now I will put this blue litmus paper in this. Okay. So what is happening here? You can see here the blue litmus paper is turned into red. See, the upper part is blue but the lower part is red. This means what? This clearly tells us that when non-metals oxides react with water, they produce acids. And acids, how we confirm that this is the acid? Because it has turned blue litmus paper into red colors. Is it clear to you? So this is what one of the chemical properties of metals and non-metals. So we will conclude this session that metals when react with oxygen produce metal oxides, and when metal oxides reacts with water they produce bases. Okay, and when non-metals react with oxygen they produce non-metal oxides, and non-metal oxides when react with water they produce acids. Okay, is that clear? Yes, thank you.